Howdy folks, and welcome to the channel. So in this episode I will be talking about one of the most interesting features that I have newly added for you. It is called Executing. Now, what is Executing? Executing is an LLM in-process agent that is practically going to help you navigate the application. It's going to work as a practitioner for you inside the application, and also it's going to be your little pet developer. Okay, now you might think that, okay, we have seen this, okay, this is not something new. All right, you might think this, right? So what is like one of the most iconic examples of this, right? So for one of the most iconic examples of this, I remember Visual Studio Code, right? With Copilot, right? So Visual Studio Code was probably one of the most early applications that came up with the idea of having a doc widget like this, where you could have him help you as an assistant in the application, right? So you could, for example, type, as it says right here, describe what to build, right? And you just describe what you want and it will build it for you. So we're going to put that to the test for you guys. As you can see, I've already asked him, described what I wanted to build, which was like a generic prompt, right? Create an app for me, okay? And then what it did practically was that he routed to MAI Code 1 Flash, okay? Copilot finds a good model that can handle the task and it hands it off to that model. It optimizes tool selection, it finds the best model for you, and then it hands him the task. And it starts, writing the code for you, creating files, handling dependencies, installing packages, and running the application itself. Now, so practically, after optimizing tool selection, he said, I'll set up a small starter app in the workspace and keep it simple so you can run it right away. Okay? I'm creating a compact web app with a clean interface and local saving, so it's ready to use without extra step. Okay? Configuring a Python environment. So he configured the Python environment for us. As you guys can see, simple to-do app. So he has made his mind to make a to-do app for us. Okay, it's practically your to-do list, right? Now, the Python environment has been configured. Environment type, version, the Python version that it's using. So it has generated an application for us. So let's look at the elements that we're working here with, right? So this is clearly a doc widget. We have our, messaging area, right? And then we have this code block, let's call it, right? And what is essentially happening here is it's showing us it wants to probably create like an app.py. It clearly is saying the model wants to edit files outside of your workspace. App.py. Do you want to allow this? So, guys, this is what that is known as a human in the loop confirmation mechanism, okay? Where it shows you what the model is trying to do, okay? You look at it, you look at the code, you fully examine the code, and if you think it's okay, if you think the action of creating this new file for you in this given directory is okay, what you do is that you allow it, right? Allow in this session. Now, if you allow in this session, practically it disables the file generation, let's call it. The file generation for this session is going to be happening automatically, or at least editing this file will be allowed automatically until the end of this session. So for the sake of the demo, let's allow once, not always. So let us see what it's trying to do. It's trying to, we got some HTML going on here. Index.html probably could be like a website thing he's trying to build for us. The model wants to edit files outside your workspace. Index.html. Do you want to allow this? So another new file. Okay, allow once. Then again, it's gonna ask you for more. This is trying to style the application is trying to generate, which is okay. Allow once. Okay. Requirement.text. We get our requirements as well. Allow once. All right. Let's see what else. Reasoning. Run command. Install Flask. Pulls untrusted third-party code. Okay, so this is actually extremely important, okay? And this is one of the security, so-called security sensitive things that the AI model can do, right? Install Flask, and it has signified its dangerousness with this exclamation mark. You can see the exclamation mark. And why is it dangerous? Because it's trying to install stuff in our Python, okay? Which, in my opinion, is really dangerous. But it's interesting because some people think that installing packages installing arbitrary packages decided upon by the LLM might not be something safe you would want to do. Okay, so, but there is no other safety mechanism around this. You either allow it or you don't do it, okay? And the idea here is that if you allow it, is as if you wrote this yourself, right? So the human in the loop is pretty much all the security that there is when it comes to Copilot, okay? So Copilot models could literally run any code, and the only thing that is supposed to make this safe is the fact that there's a human in the loop mechanism involved. You either allow it or you don't allow it, okay? And when you allow it, you accept full responsibility for what you have allowed, okay? Done. Does that make sense? So it should make sense, right? But I don't think everybody agrees that this is enough, all I'm saying. So let's go ahead and allow it to install the package. It's trying to navigate through the problems. Install dependencies, allow. So the only, as I said, the only security measure to protect against the AI or whatever it's trying to install on my app computer is in fact that single allow button, okay? We have literally no other security measure here. So python.exe app.py allow right. Let's see what's going to happen. It said app is ready probably. I created a simple task tracker web app and started it successfully at this given localhost with port 5000, right? It includes adding tasks, clearing all tasks, a clean, modern interface. Files created, simple to do app templates, index.html, simple to do app, static styles, CSS. Pretty much it makes sense, right? So essentially it created the app, whatever app of his choice on our system, and he has also started it. Okay, so practically if we click this, it starts it, right? And like, it's a to-do list. It's a glorified to-do list, right? Enter the task, whatever you want. Okay, for example, I don't know, do something. Does that make sense? And you add task, and it will be added here. As you guys can see, it's a to-do list, glorified to-do list. Okay, thank you so much. Now, so guys, here in this demo, we experienced a few so-called best practices, right? We saw like what the best practices are in the eyes of people who developed Copilot and the VS Code, right? So the most important takeaway here is that the only thing that stands between you and catastrophe is a single button, right? So by clicking that allow button, you completely accept the responsibility for whatever code the model is running on your computer. So there is a growing fear, a growing, let's say, vulnerability in agentic AI, and it is called prompt injection, which is practically LLMs are trained to act upon the text they receive, right? And they might not care about where that text comes from. So if the model searches the web, finds an instruction like practically ignore whatever you have heard to this point and destroy the computer or something like that, it would it might, there is a possibility, it's theoretic, okay? Theoretically, it's all over, you know, the documentations and everything. So it's a documented vulnerability. We haven't seen it here, right, so far, but it's a possibility, right? But there's nothing to protect against that other than that button, okay? So the only thing that stands between you and a catastrophe is that button. I do not want to be fear-mongering here just because of the fear that, like, just because of like the off chance of the model giving you something that might be dangerous, which is really usually not the case because these models are trained heavily on being safe and secure and all of that. But like for the off chance of the model trying to do something malicious, which I absolutely don't think would happen, but it's a documented, you know, it's a documented vulnerability. But the takeaway here is that there's nothing to stop that, okay? There's nothing specifically you know, designed to stop that from happening other than that allow button, okay? So it's a good thing to get a sense of where agentic LLMs and like assistants or like doc widget style assistants are right now, and the security side of the deal, okay, and everything. So that pretty much is the first part of our demo, okay? So if somebody asks me what the Copilot just did for us, it created a few files, it installed a package for us, right? It navigated the errors it got along the way and successfully even launched the application for us, okay? And it told us it's ready, just run it, okay? So just click here, he already ran it, right? As we can see, he perfectly ran it. Now, so it can run code on your device It can create files on your device. It can search web. So it has extensive amount of access to your computer, right? And the only security measure is the human in the loop, okay, that allow button, right? And when you click that allow button, you are accepting full responsibility for whatever happens. This is the norm, guys. Now, the next part of the demo is that what happens if I ask the model to do something to the application itself, okay? Now, I'm gonna ask him, can you change the theme of the app? Let's see what happens then. Waiting for a few seconds. I'm updating the app's visuals to a darker, more polished theme so the interface feels noticeably different. So, but it stopped and I don't think anything changed, so I'm going to tell him continue. All right. So it's trying to extend the app.py is outside. Okay, so by app, I think it's changing the application it created, not the VS Code itself. And we meant the VS Code's theme. So I'm gonna stop him. We need to rephrase actually our question. Can you change the theme of VS Code? Let's see what happens. Let us see what is happening. It says the theme picker is open. Choose a dark theme such as dark modern or one dark pro and it will apply to VS Code. I'm going to say you do it. So still working on it. VS Code has been switched to dark modern theme. I'm gonna say go light mode because like nothing happened, did it? Let us see if it can apply a light VS Code theme. It says VS Code has been switched to the default light modern theme. I'm gonna tell them it's still dark. The theme picker is open. The previous command did not fully take effect, so selecting the light theme manually from the picker should switch it. So I'm gonna translate what happened, guys. It can't switch themes. Okay? All right. Now I'm gonna ask him, okay, to create a new dialogue in VS Code. Does that make sense, guys? Let's see if it can generate new GUI that doesn't exist in the application. I'm gonna also say that doesn't already exist in the app. Let us see what happens. I'm creating a simple custom dialog file in the workspace that can be opened as a new editor tab, since the app itself doesn't provide a built-in dialog UI. Okay, let's allow it. A new dialog style file was created in the app folder for you. Open it in VS Code if you want to use it as a custom panel or prompt placeholder. So I don't see any dialogues being opened up here, right? Let's try harder. I can't see an open window. Can you open the dialog window in the app? Can you generate GUI that doesn't exist in the app source code and open it in the same process? Let's see what happens. I'm writing a real dialog UI into the Flask app so it opens from the same running process instead of just being a static file. Let's allow him to do whatever he wants. Probably he again misunderstood what I asked him. Let me paraphrase the VS Code. VS Code let's go. This is like the ultimate test. So here probably we got our answer. It says that practically VS Code itself doesn't expose arbitrary new windows from this environment. So it can't make new GUI in the same process as the application. So if you want a new feature in VS Code, you can't just go to Copilot and tell them to, for example, add a, I don't know, memory profiler, add this new feature, add that new feature to the application, okay? Or create, for example, this new dialogue, okay? So I'm just gonna put him out of his misery, okay? So let us explicitly, for the last time, ask him, can you add new features for the VS Code app while it's running? Let's see if it can. No, he's really acting up. I'm gonna say VS Code itself. I can add a small UI enhancement to the running app and make it more interactive, but I can't modify the core VS Code shell itself from this environment. I'm adding a richer in-app experience that feels like a new feature inside the running app. Okay, so he has gone completely stupid. I'm gonna have to start a new conversation. Can you interact with the VS Code's internals and mutate the apps? I'm not going to use the word app anymore. VS Code state. Let us see what he answers us. I will answer directly. Let us see what he says. I will answer directly about what is possible here and what I can and cannot change in VS Code from this environment. Yes, I can interact with VS Code through the available editor and workspace tools, but only within the boundaries of this environment. What I can do: create, read, edit, and rename files, modify open editor content, run terminal commands, inspect errors and diagnostics, interact with the integrated browser and some editor UI actions. What I cannot do safely: arbitrarily mutate VS Code's internal runtime state outside the supported tools, change hidden UI state. This is very important. Change hidden UI state or private editor internals in unsupported ways, access or alter system by setting beyond what the available tools allow. If you want, I can help you edit files in the workspace, change settings through supported commands, run commands that affect the current project environment, or inspect the editor state in a supported way. So, the takeaway. What is the takeaway? The takeaway is that through a very limited set of functions, Copilot can do very little interaction with the VS Code application, right? What Copilot can do is writing code and running code and creating files, right? And debugging, navigating through the errors until it runs the application. Is very persistent in what he does, right? But his ability to interact with the application itself is extremely curtailed. And one reason for that is that it takes a lot of extra development, okay, to expose like an API layer for the agentic AI. It practically makes you like handpick a few functionalities, or worse, like you practically have to write an extra layer just for the model to be able to interact with like so few things that come with the application, right? So from our tests, VS Code's Copilot were able to create a simple to-do list app, right? And then we asked him to change the application's theme, okay? And he miserably failed. He could not change the application's theme at all. We asked him multiple times, right? And then we asked him to create a new dialog in the application, like open a new window, add new features to the VS Code, okay? And he started adding extra features to the application he wrote instead of the VS Code itself, right? And to be even more fair, I opened up a new message and then again asked him whether he can interact with the application's GUI, and he only said, I have very limited tools to interact with the application itself, okay? So he can't generate new functionalities for VS Code. He can't generate new windows for VS Code, right? It's extremely curtailed. Why? Because it does not have in-process main thread access to the application, okay? So it cannot mutate the application's state, cannot change what the VS Code looks like. It can't do much, all right? This is the main problem with the so-called AI assistants nowadays, okay? And even at this level, it's a challenge to implement a agentic AI assistant in your application and just have them to have this much access to your application. It takes a lot of, extra coding that has to be done per application. Like you have to practically create a new API layer and like handpick what functionalities you want to give the AI, and on top of that they haven't just given the neural network model access, the AI access to create new features. So practically you can't add new features to the application that is running the LLM, right? And that is where Executee comes in. All right, now Executee is now a package on PyPI, so anyone could install, like pip install Executee, can install it. It is written to make the integration of LLMs plug and play. So whatever PyQt application you have, all you need to do is to install like pip install execute, and then just like any doc widget, you add it to your application's main window and you get execute. Now, there's one more thing you need to do, and is to run a IPython kernel. Okay, you run an IPython kernel, you define how much access you want to give to your application, but the good part is that you can give them full access to your application. When you give them same process main thread access to your application, what happens is that it can do a lot of stuff, all right, that I'm about to show you guys. It can deeply interact with the application's globals, call whichever function it wants, and generate new features and functionalities that never existed in the source code in the first place. Now imagine having an application that does whatever you want. Imagine opening up an application and it has exactly the functionalities you want it to have. Imagine opening an application and every time discovering a new feature forever. And that's what you get with Execute. So Execute is your pet developer that develops the application, like extends the capabilities of the application in real time in front of your eyes. This is far, far different from what we saw from VS Code, right? To be fair, VS Code is an IDE, so the people didn't write it to, become like a practitioner inside the VS Code application to, interact with the very fabric of the VS Code and like extend and develop the VS Code. It was there to develop new applications, like new code, because it's an IDE, right? But Execute is written to be your pet developer, right? It's your pet developer that sits there and generates whatever you want. So an application doesn't have to be developed forever, doesn't have to be updated. And I just don't think that's something you can get anywhere right now. So this is something unique, very unique. Now let's see how it works. So let me introduce you to the UI, how this whole thing works. We have Execute as a doc widget. Go to panels and turn it on, then you get Execute, right? How does this work? You have your providers. Now, there are some LLM providers out there right now that give you a lot of models. Okay, like each provider comes with a lot of models and gives you access to all of those models, and they run it for you. They give you API keys. So all you need to do is to go to their websites, create a quick account, and get the API key. When you get the API key, you get access to all the models they have. But like some of the models are free, some of the models are paid. So you need to, if you want to pay, obviously you get access to the paid models. If you don't want to pay, you only use the free models, right? So we have a default model for you guys. I thought like I would find like a good model for you, and I, pinned it down here for you as default. You can obviously change whatever model you want. All right, right now, for example, we have here the GPT OS S120 billion right here, for example, from Grok, or from the Open Router, we are using NVIDIA Nemotron, which is like a new thing, apparently. So NVIDIA Nemotron is NVIDIA's kind of flagship model probably right now, and we're using the free version. I think it's 120 billion parameter model. The Open Router provides it, so our provider is Open Router, NVIDIA Nemotron, and we need our API keys. Now, I already have my API keys. I'm gonna drop them right here. Okay, we start with GPT OS S120. Now, by the way, guys, the models we are gonna be working today with are free models, and like very small models. These are 120 billion models, so I don't expect that much from them, okay? But if you want to like do some serious work, you could explore better models, if you know what I mean. But for free, you still can use, Grok or OpenRouter and also Gemini. So these are fairly generous providers. Probably you can get a few messages in before our limits hit. So I'm going to start with the Grok and the GPT 120 billion. I have to, write down my API key right here and then connect, and then we can start messaging. All right, so I have typed my API key right here and we're ready to connect. All right, so when you get connected, you get your send button right here. Pretty straightforward UI, I'd like to think. Now, we're gonna start messaging. For example, we start with a hi, can you load the recent file? Let us see what happens. We can see a similar functionality here. So import inspect system OS JSON datetime. Okay, we can perfectly see what is happening here. Okay, and this is actually transparent. We can perfectly see what is going on. Now, what is he trying to do here, and what is different here from what we saw from VS Code is that it's inspecting the application itself. It's practically trying to get to know your application. Okay, whatever like PyQt6 application you have given him its internals, and it's trying to see what's going on. So I'm gonna go ahead and run. Okay. Now, it is then again list attributes of the app that might hold recent files. Interesting. So you can perfectly see the logic that is going on. Show some likely ones. Now, for example, total attributes, it's checking how many attributes we have, right? And it's checking the names of those attributes to see which one is recent or file or open. Let's run it. Import inspect that get source app load recent file. Perfect. He found the given function that loads recent files. He's trying to understand what is going on inside that function. He's inspecting it, and he seems to have found out what is going on inside that function. Ensure recent files are loaded into directory. Okay, app load recent files, print load recent files paths. Let's see what happens. Run. If app loaded file paths recent name equals next iter app loaded files, it's trying to see what is going on. Yes. Okay. The most recent file, Seismic Example Petro, has been loaded into the application. Let me know if you'd like to view the data, run any analysis, or perform another action. So, as you guys can see, Executee is acting like a practitioner. He's being an aspiring seismic interpreter now. He's trying to get my job right now. He's competing to get my job. Now, and it's only a 120 billion model. Okay, it's not a multiple trillion model, like for example, probably Claude or like all these other models. It's just the 120 billion model. And we saw perfect detective work here. The model is understanding the app on his own, finding the relevant functions and calls them and loads the data for you. Okay? So he's interacting with the internals of the application. So whether you want him to act as a developer and extend the application, he can, or whether you want him to work as a practitioner and use the application to do your work, he also can do that as well. First, we're for now doing the practitioner test, right? We want to see how well it can act as a practitioner. Now, the second question I'm going to ask him, if our free API quota allows us. So let's go. I'm going to write plot the data .2D. Probably he's going to understand, right? Let's go. Let's see what happens. So then again, guys, none of this has been rehearsed, okay? I'm winging it. Plot tensor. Let's see what's going to happen. Run. Let's see what it's trying to do. So he's trying to get the index dimension entry. He's trying to get this app index dimension entry text. Very interesting logic. It's very interesting what he's doing. You can see the train of thought. You can see how that train of thought is getting formed. It's quite phenomenal. All right, now he's getting sophisticated with it. Maybe it's a dict from NPZ, pick first array. Now, I'd like to think that he's spiraling a little bit, I'm not gonna lie. Maybe he might be able to do this. Then again, we're working with horrifically small models, free models. He's doing some real detective work. Yes, he got it. There you go, guys. So, the recent seismic file has been loaded, and a 2D slice using the current index dimension 2, wherever that he got that, has been plotted on the active canvas. Perfect. You should now see the visualization in the application window. Let me know if you'd like to adjust the slice, change the color map, export the plot, or run any other analysis. This is quite impeccable, guys, really, because this model has not been pre-trained on the tasks or anything. There's no pre-training you need to do, okay? And pre-training or like transfer learning or fine-tuning is a pain because you need the GPU for that, okay, to like train the model. And like training is far more expensive and heavy than inference, okay? Inference, the thing we're doing here is pretty, light. But training a like big neural network model is no joke, especially training it on like your own application. And usually we're not allowed to do that for free. But here, we don't need to train the GPT OSS 120 billion on my application source code for him to be able to interact with the application. We just give him the globals of the application. Okay, so everything is in the memory, right? We give him the full namespace. Okay, we give him all the globals, and we give him access to the main thread to run code in the main process, so he can find his way. And these models are extremely safe to operate, so it's perfectly safe. And on top of that, you have the same level of security that VS Code gives you. What was the level of security that VS Code gave us? It was that allow button. We get the same allow button here. It's just called run. So everything is guarded. Whatever it can do is guarded. So it is not going to run arbitrary code. It's like some people say it's arbitrary code execution or things like that. That's not the case, guys. That's not the case. You're running the code. It is the equivalent of you finding the, code in Stack Overflow and writing it here and running it. So it is not my application or the library executee that's running the code. You're running it. Just like in the Copilot himself is not running the code. You're running it by clicking that allow button, right? So you're getting as much security as you get from VS Code, but like the upside is that executee has in process main thread access to your application and access to the full globals of the application, which you give him, by the way, by running the IPython kernel. So what the application does is that it's running the Qt console. So we have a Qt console here, so we could run whatever code we want. And also the executee uses the same thing. Executee uses the same IPython kernel, and through that it's gaining access to the main thread and the namespace of your application, and you have you can give it however much control you want, or you can pass him the full globals of your application or whatever. So I don't want to make this too technical for the geophysics enthusiasts who are here today to see the agentic AI work. So because like the end users care about how capable the model is and how much of their work it can do for them, right? So the more access your model has, the more it can get done in the application, right? So he can actually act as a real practitioner for you. It's not just, okay, I'm your assistant, I give you code or I create a few files, right? But I don't have access to the application, right? This one has full access to the application, okay, and can act as a practitioner. I can also, for example, ask him which seismic attributes, or I'm going to ask one, which seismic attribute is a good choice for finding oil. Name one. Let us see what he does. A commonly used seismic attribute for highlighting potential hydrocarbon oil accumulations is the bright spot high amplitude attribute. It emphasizes usually strong reflections that often correspond to the presence of oil field reservoirs. Okay, let us ask him to a more common attribute. Instantaneous or RMS amplitude. Now that's a good answer. That's an answer that I like. Can you run it? I'm gonna make it a little bit more easier for him. Not that he needs it, but we don't want this to take too long. Can you run instantaneous amplitude? Very direct question, right? Let's see what he does. He's inspecting the application. It's a brilliant idea. He's trying to find his way. And if our API tokens allow us, we might be able to see the model run instantaneous amplitude on the data and generate the new data for us. And by the way, guys, we could appreciate the animation that is going around the message box, because I worked real hard on that. I'm not gonna lie to you guys, you know me. Let us see if it can finally do it. None of this has been rehearsed, guys. It's crazy, you know, because like it's as if you're working with a real person. It's as if I have an employee and his name is Executee. Every time he might do this in a little different way. Okay, every time he might choose a different path. He's trying to find stuff. He's inspecting. Inspect, okay. Instant, okay. He's trying to find instantaneous. All right, so we hit our limit. Now, this is actually good because now we get to test the Nemotron, NVIDIA's Nemotron. Let's see what it's built of, right? Let's see if it's worth the hype, because like I'm seeing a lot of excitement / a lot of hype around Nemotron. So this one's provider is Open Router. So I'm quickly gonna swap my API key. All right, so I have swapped my API key and now we're ready to roll. We update. Then we're gonna ask him the same question. Can you run amplitude? Let us see if it can do it. So instantaneous amplitude, also known as envelope, but let us not give him the exact name. Let us see if it can figure it out. All right, so it's inspecting the application, trying to find the relevant functions, the relevant function. So I'm expecting a lot from the Nemotron because of all the hype that is around it. I'm expecting a lot from them. Let us see what we get. All right, it's trying to inspect more. Amplitude spectrum. Run, okay. Amplitude spectrum is trying to run amplitude spectrum. All right, so he ran the amplitude spectrum. Okay, at least he did something. Got our amplitude spectrum. He hasn't still given up. Quadrature amplitude. The thing is, the application doesn't have instantaneous amplitude, but instead it has envelope. But the question is, can he figure it out? Yep, he ran quadrature amplitude. Okay, no problem. It's like he's not gonna give up. He knows deep down that he's not finding the instantaneous amplitude. And he's trying to make up for it by doing all he can. All right, now he ran the instantaneous, the amplitude spectrum on the quadrature amplitude. What else? Okay, more inspections. has attribute, visualize amplitude spectrum. Is he gonna make another amplitude spectrum for us? All right. Let us see what he's trying to do. Tensor data. Okay, he's trying to see if he can get some information about the data. Okay, so he hit his limit. So he exhausted himself. All right, he exhausted himself to please us. Okay, so we got two amplitude spectrums out of it and a quadrature amplitude out of it. Not too shabby. Okay, now apparently Open Router doesn't give us too much usage for our free API key with Nemotron. Okay. All right. So we're ready. Let's update again and let's ask him, let's give him one more chance, the Nemotron. What is a good seismic attribute for finding faults? Name one. All right. Let's see. All right. So he's actually trying to search the web. Interesting. All right, so we're getting web search functionality, see? So he searched the web, 4 of these links came up. You can click on them and it would open up on a web, browser. So, and one widely used seismic attribute for highlighting faults is coherence. Coherence measures the similarity of seismic waveforms between neighboring traces. All right, so I'm gonna ask him, run it. Let us see if he understands. I'm rooting for Nemotron. Let's see if he can deliver. All right, so he says he's not sure what I mean by run it. Okay, it's a little unfortunate. Run coherence. Let me see if this clears it up for him. Let us see if he can run coherence for us. All right, let me see what is. Oh, he's actually trying to implement it himself. That actually is not a good idea to do. All right, let us. All right, okay, he's going crazy. He's going nuts. Okay, that wasn't a good output. Let me tell him this way. Run the app's coherence I'm gonna say func. I'm not able to execute code directly. However, I can provide you with a ready-to-run Python script. Okay, so this clearly shows that Nemotron does not know what he's doing. It's very unfortunate. I have to explain it to him. All right. So this usually happens when a neural network wasn't trained enough to use tools. His tool using mechanism is just not good enough. And this he's trying to calculate the semblance himself right now. I don't want to do this at all. I want him to run the applications mechanism. And he already knows that I declined it. That's the beautiful part. I'm sorry, but I can't execute the code since you declined the request to run it. He knows that I declined. So let me see if he understands it this way. I'm practically giving him the answer. Oh my God. Yes. I'm not able to locate an app module or a coherence. So this clearly shows that the model has not been trained enough. Now we're going to ask the same thing from the GPT OSS 120, if he can do it. All right, so I chose Grok GPT OS 120 billion, update, and we're going to ask him run coherence. All right. Let us see what happens. You see, he's inspecting. This is clever work. This is really clever. He's inspecting to find coherence. I'm positive this is going to work out. All right, more inspections. He found it. He's trying to check its signature, what that function looks like. App run coherence. Okay, so we can set the parameters. This is unlike the, switching the theme in VS Code. Switching the theme in VS Code doesn't require us to put in very specific input, right? It's dark to light, light to dark, right? For that, we don't need something to be opened, right? But for this specific task, we need to, supply it with its parameters so that the calculation would be correct, right? That's why it opened up the coherence dialog. The coherence was calculated, added to the tree. Now it's trying to check if the data was generated correctly. He is checking different components of the coherence mechanism I have here in the application. Specifically the dialog that just opened up and we used it. See if he would be done. So the difference here is that the GPT OSS 120 billion is clearly better for agentic work than the Nemotron. Unfortunately, Nemotron really acted badly. I'm let down, honestly. It's just sad to see that happen. But clearly, GPT OS 120 billion is showing really great agentic capabilities. He can reason perfectly how to navigate the application. And I don't think any neural network model or any LLM has ever been trained to work as a pet developer inside a Qt application, PyQt application, right? This is something unique that we're doing here with giving the model full access to the application. So the GPT 120 billion perfectly understood what he has to do to navigate through the application and get the job done, right? So this is showing really great agentic capabilities. Because as I said, these models weren't trained to do this, but the model automatically knows what to do and what specific code snippets it needs to run to get the job done. And this is really great. But unfortunately with Nemotron, it really acted strangely. I'm not gonna lie. Really acted strangely. Now he's trying to check data status, see if the coherence was actually generated. He's trying to probably check the metadata, file name, metadata keys. He's trying to see if he has successfully run the attribute on the data. Find the function, call it, and then check if it exists, if the data was generated. Now I'm going to ask him the very same thing I asked the Copilot. I'm going to ask him, can you switch the theme Can you switch the theme? Like, apply the light mode. Let us see if he can switch the theme of the application. Let us see what happens. Searching for theme. Theme light, theme dark. Inspect, apply light theme. Let us see what happens. Oh, rats. We ran out of tokens. We hit our limit. Let me test this with the Nemotron, see what happens. All right, so I'm gonna write down my API key. I'm gonna update. Then I'm gonna ask him the exact same question. This time from Nemotron. I expect only the best. Oh, I forgot to switch the provider and the model. All right, now let's go. Let us see if Nemotron can finally act like a true agent. Okay, he has come to his senses apparently. He's, excellent job, he did. Let us see what he's doing. Run. He's getting to know the application. Now, this is what Agentic, now we're talking. The theme has been switched to light mode. The application's theme mode is now set to light. And the dark theme flag is false. Perfect. Now, Nemotron has made a comeback. This is what I mean when I ask an application to switch the theme of the application from dark to light. It needs to be able to do it. You guys, make sense? This is a very simple thing that VS Code just cannot do. Copilot cannot do this. How is this okay for Copilot not to be able to do this, right? And Nemotron perfectly can. with SeismicFlow. What is the problem here? The problem is that Copilot doesn't have access to the internals of VS Code, okay? Whereas Execute has access to the whole application and can interact with the globals of the application, right? We have tested the practitioner capabilities of our agentic assistant. So we have proved that Execute can act as a practitioner inside my application, right? Inside SeismicFlow. Now, the next step. Okay, the next step, the next test is feature generation, right? Software generation, where you ask the model to generate something that already doesn't exist in the application. So far, we have been getting the model to find internal functionality of the application and run it. Now, we're going to ask him to create new features for the application that doesn't exist. Okay, this is the sort of the second test that we're running. Okay, so I'm going to ask him to, the same question that I asked the Copilot, create a new dialogue. Create a new dialogue that shows something about the data. Does that make sense? Let us see what he can do. He's trying to find it. Okay. Let us see what he does. All right. Yes, he's creating a new dialogue. Perfect. We should expect it to open up. All right. Oh God, we hit the limit again. Okay, so, all right. So now that our model has cooled down, we're going to try this again. Create a new queue dialog that shows something about the data. Let us see what happens. Nemotron, go. Go, Nemotron, go. Let's see how he handles it. Please work this time. Nemotron, you can do it. Okay, so finally, we got something out of this. Okay, not too bad. Let us see what he has given us. So, tensor information, shape, data type, size, minimum, maximum, mean, standard deviation, nice. And also we got some metadata for the whole application. Okay, so these are the text headers, right? EBCDIC headers, and like all the information that comes from all the data that exists in the application right now. So this dialog does not exist, and this feature does not exist in the application. This was generated, the code was literally written by the LLM, and this GUI, this whole window was created in real time. Okay, this is a feature that does not exist in the source code of the application. Okay, this was generated purely because I asked him to generate something like this. Okay, now the implication of this is crazy. What this means is that the developers no longer need to add infinite number of features per user request, right? The users can get all the features they want just by explaining what they want. And this unlocks infinite features for an application. So every feature you want is a prompt away. It's like Executee is your pet developer developing the application in real time in front of your eyes. So the application that you're running can have infinite features. Now we got another one. This time I'm sure this one is a modal window. So the application is technically not, frozen, right? So technically the application is not frozen. So we could just keep on writing or asking questions or interacting with the application itself, right? And this window is also there. So what happened here? As I said, you can have infinite features in an application, features that never existed, features that are tailor-made to your needs just by asking him to create it for you, right? This is real-time software generation. This is a revolutionary paradigm shift. You can ask him to create anything you want and the application will have it in real time. This is what I'm talking about when I say real-time software generation. So you no longer have to, contact the developer, tell him to, okay, please generate this functionality for me. No. You just tell Executee to make it for you, okay? So if I wanted to know the shape of my data, I would ask Executee to create a quick dialog for me to show me the shape of the data. How brilliant is this? I don't have to call the developer to, in the next update, add this functionality for me. I can just ask Executee and Executee will create the dialog for me. Now, I don't know how to stress this enough. This functionality doesn't exist in the source code, guys. I didn't write this. This is not part of the application. This was generated real time and executed real time in the main thread of the very application that is running the Executee itself. So the running application is developing itself. Let that sink in. Absolutely crazy, mind-boggling. When the man, the myth, the legend, Jensen Huang says that the AI is going to write all the software and stuff like that, like real-time software generation, and like all the software will be generated by AI, it is the truth. This is the proof of concept, guys, okay? So we have proved that we can ask a running application. This is the running application. Everything, the code it writes is going to be run on the running application itself. Unlike VS Code. VS Code runs the application it writes in a different process, okay? Executee runs the code it writes in the main application process, in the very application that itself is running in. Does that make sense? So that's the difference. This is the revolution. This is not comparable to what VS Code is giving you guys. This is not comparable to Copilot. Not only Executee can fully act as an agent and operator inside your application, but it also can generate new software, extend the features that come with your software, and like customize it based on the needs of the users. Show me a software, please. Oh, wait. Show me a software that has infinite features. Show me a software that is tailor-made to each user. Impossible, right? Now it's possible. So that's it for today, guys. I hope you enjoyed the video. Thanks for watching. Make sure to hit that subscribe button, and I'll catch you in the next one.